Alright, you guys, round 2 on complex fractions. So in example 8, we have another complex fraction, which, if you thought you understood example 7, I highly encourage that you try this one on your own. So go ahead and pause the video and fast forward to the end and see if you get it correct. Alright guys, so when we do complex fraction, we have the same steps as before. So I'll be referencing the steps that we used in the previous problem. So the first step, we must only have one fraction in the numerator and one fraction in the denominator. Which, remember you guys, this is my numerator, and this is my denominator. Okay. Alright, what's the denominator? I already have one fraction, so that one's good to go. But this silly numerator keeps giving us trouble, you guys. We have two fractions in the numerator, so we must put that to an end. Okay, we're going to do that over here. So we're going to focus on the numerator, and we're going to make that bad boy have one fraction up there. Okay, so I have 1 over x plus 1 over 2x. Alright guys, so remember when we have two fractions and we're adding, the first step is to try to factor the denominators. Which, since I have 2 degree 1s in my denominator, I don't have to factor them. Okay, so my factoring's done though, which that means I need to come up with a common denominator. Bam, I'm going to abbreviate it with the CD. So remember you guys, with common denominators, I grab one of every different thing in the denominator, and if they share something in common, I grab the one with the highest exponent. So let's see here, my x, I got an x in both terms. Oh no, what do I do? Which one do I pick? Well, these both are secretly to the first power since I don't see ones, I don't see an exponent. So since they're the same exponent, I just pick one of them. So I have an x, and then the only thing left between my two denominators is a 2. So my x times 2 is 2x. So this is going to be my common denominator. So I need to force both fractions to have a common denominator, whether or not they want it. Sorry, buddies, you're donezo with your unlike denominators. Just saying. Alright, so this one has an x in it. I must make it a 2x though. So I have the x. So what it's missing is the 2. So I'm going to multiply this bad boy by 2 in the denominator, which means I'm going to have to do it in the numerator. Okay, and then my second fraction, I have 1 over 2x, which, guess what, you guys, is already the common denominator. So that one's good to go. Okay, so I need to multiply these together, which, remember, when we multiply with two fractions, we go straight across. Okay, so this is going to be, 1 times 2 is 2, so it'll be 2 over x times 2, which is 2x. And then, yeah, just going to bring my other fraction over. So now that I have a common denominator, I can add these bad boys. Okay, which I got my 2x, my common denominator. And then I just need to add the numerator. So 2 plus 1 gives me 3. So this is now going to be my new numerator, which I'm going to write over there. Okay, so now this thing is 3 over 2x. All over, divided by x plus 4 over x minus 2. Alright, so my first step is donezo. We made one fraction in the numerator and one fraction in the denominator. So step 2. We're going to rewrite the fraction using the division symbol so we know how to divide with two fractions. So it's this divided by that. So my numerator divided by my denominator. So let's go. So this bad boy will equal, alright, we have 3 over 2x. My fraction symbol is going to turn into a division symbol. Oh yeah, dog, right? Alright, and then divided by x plus 4 over x minus 2. And guess what? We know how to divide with two fractions. You keep, change, flip. So I'm going to start with my 3 over 2x. What's here? So it's going to be 3 over 2x. So we keep, change division to multiplication, and then we're going to flip the second fraction, or find the reciprocal. So it'll be x minus 2 over x plus 4. Alright, guys, and remember, before we multiply, we try to factor all the numerators and denominators. Remember, when you add and subtract, you only factor the denominators at first, and then at the end you factor the numerators. But when you divide and multiply, you factor everything at the start. But I can't factor anything because they're already all degree 1, so that makes my life easier. So now all I have to do is multiply, which means I multiply straight across. So this will be 3 times x minus 2 over 2x times x plus 4. Alright, guys, and the last step is to divide the fractions, and we're going to divide out anything that we see that's in common. Which, remember, we can only cross out things that have multiplication in between. If I see any addition or subtraction, those things are illegal to cross out. Okay, so the things I'm allowed to cross out, the things that secretly have multiplication between, these two are secretly multiplying. This is secretly multiplying to the x, and the x is secretly multiplying to the x plus 4. So the only things I can cross out are a 3, an x minus 2, a 2, an x plus 4. I can't sit here and be like, oh, I see 2 x's, let me cross them out. Because guess what? The demon cats are coming for you, and I'm highly concerned about your life at this moment. Okay, so you cannot cross things out that have addition or subtraction in between. It's either all or nothing. You got to cross out the whole thing, so watch out. So is there anything in here that I can cross out? Anything that's the same in the numerator and the denominator? No, there's not. So guess what, you guys? This is my final answer. So my final answer will be 3 times x minus 2 over 2x times x plus 4. Yay! Complex fractions are our friends, and they're actually not as complicated as we thought. Look at that lovely problem. Just soak it all in. Oh man, that's awesome. It was great.